In this lesson, we're going to go over the acetoacetic ester synthesis reaction. And so in this case, we have this molecule, ethoacetoacetate, or ethoacetoacetate. And we're going to react it with ethoxide. Now, I don't know if you saw the last video in my playlist. It was entitled the malonic ester synthesis reaction. And the malonic ester is used to create carboxylic acids. This reaction, the acetoacetic ester synthesis reaction, is useful for making ketones instead of carboxylic acids. But the mechanism for these processes are very similar. In the first step, the alpha hydrogen will be removed. And in the second step, we're going to react this species with an alkyl halide. So let's use ethobromide. So the carbon with a negative charge will attack this carbon, expelling the bromine atom. Now the next step in the process is to react this molecule with H3O+. And so what's going to happen is the ester is going to be converted into a carboxylic acid. And so this is what we now have. I'm going to redraw that here. In the next step, what we need to do is we need to react this with, actually we just need to heat the solution. So once we heat the solution, decarboxylation will occur. So we're going to lose the carboxylic acid part of the molecule. And so we're left with a ketone. So this is a 5-carbon ketone, which we can write it like this. So we have 2-pentanone as our product. Now let's work on another example. Go ahead and try this problem. So in the first step, we're going to use sodium ethoxide just like before. And then in the second step, we're going to react it with pentobromide, followed by the third step, which will be H3O+, and then the fourth step will be heat. So go ahead and draw the major product for this reaction. Now let's write out a mechanism. So we know what the first step is going to be, and that is deprotonation of the alpha hydrogen. The next step is alkylation. So we're going to react that with 1-bromopentane. So then the carbon with a negative charge is going to attack the carbon that has, or that is attached to the bromine atom. And so right now we're going to get this product. And then we're going to add 5 carbons, 1, 2, 3, 4, 5. Now in the next step, we're going to add H3O+. And so this group is going to be converted into a carboxylic acid. Now the next thing we need to do is we need to react it with heat. We need to increase the temperature. And so that's going to promote decarboxylation. So we're going to lose the carboxylic acid molecule. And so now let's count the longest chain. So the longest chain contains 8 carbons. And so we have a ketone on carbon 2. So this is the product, 2-octanone. And so that's it for the acetoacetic ester synthesis reaction. As you can see, it's very useful for making different types of ketones. But so far, we've only considered ketones with one R group. We can try an example where we can add two R groups. So here's the generic formula of ketones that we can make. We can add the first R group or the second one. And we're adding the R groups to the alpha carbon of the ketone. So just keep that in mind. So this is the generic product that we're making. Now let's try another example. So let's react to this molecule with sodium ethoxide in the first step. And then in the second step, we're going to use propyl bromide. And then in the third step, sodium ethoxide again. And then in the fourth step, we're going to use hexobromide. And then in the fifth step, H3O plus, followed by heat. So go ahead and draw the major product for this reaction. So let's write a mechanism for this reaction. Now the first step is going to be the same, deprotonation. And then in the second step, we're going to have alkylation. So let's react it with propyl bromide. So right now we have this product. So we need to add three R groups. Not three R groups, but three carbon atoms. And then there's a second alpha hydrogen atom that needs to be removed. So let's use ethoxide again to take it off. And now we can add the second R group. So the carbon with the negative charge is going to react with hexobromide. And so we're going to get this product for the fourth step. So we've added a propyl group and a hexo group. Now our next step is to acidify the solution, converting the ester into a carboxylic acid. Now for the last step, let's add heat. And so we're going to remove the carboxylic acid functional group, and let's identify the longest chain. So this is carbon 1, 2, 3, 4, 5, 6, 7, 8, 9. So we have a 9 carbon chain. So that's carbon 2, 3, 4, 5, 6, 7, 8, 9. Attached to carbon 3, we have a propyl group. And so this is the ketone for this particular reaction. And so we can make any type of ketone with this generic formula using the acetoacetic ester synthesis reaction. Now sometimes you may need to determine the reagents that's needed to produce a certain type of ketone. So in this example, what reagents do we need in order to make a ketone that looks like this? So go ahead and pause the video. Determine the reagents that we need in order to make that particular ketone. So you need to realize that this is the first R group, or you can make it the second R group. The order really doesn't matter too much in this example. And here is the other R group. So that's R2. And here is the alpha carbon that connects them. So the first step, as always, is the use of the base sodium ethoxide. Now, in this second step, we need to add one of the R groups. So I'm going to choose this one. So I'm going to redraw it in blue. And then instead of attaching it to the alpha carbon, we're going to attach it to a bromine atom. And so that will give us this R group, as you can see. And if you want to count the carbons, we had 1, 2, 3, 4. 1, 2, 3, 4 with a methyl group on carbon 3. So you can make sure it's the same. Now in step 3, we need to use sodium ethoxide again. And now in step 4, we can add the other R group. So basically the benzyl group. And then in step 5, we can add H3O+, we can acidify the solution. And then the last step will be the same, heat. And that's it. So those are the reagents that we need in order to make this particular type of ketone. So that's all we need to do. So that's all I got for the acetoacetic ester synthesis reaction. Just remember, it's good for making ketones. Thanks for watching.